Okay. So example 1. I'm going to pick some questions that I made up that are similar to the homework. So solve for sine theta plus 7 equals 9. So if they tell you to solve it on one period, so they say solve on 0 less than theta less than 2 pi plus 7 equal to 9. So what you got to do is solve it like you normally would, but at the very end, you have to consider only the solutions in a single period. You can't keep going around. If they don't mention a period and you assume infinite number of solutions, but solving it on one period kind of helps you find the end solution. So let's go ahead and do that. So subtract 7 on both sides, right? Divide by 4. That reduces, so we get sine theta equal to 1/2. I'll just put it down here. Oh, I did that. Consistency. Okay, so technically, you could use the inner circle, right, and find the answer, but let's pretend that we're only using the calculator because eventually you're going to get weird numbers. So you do the sine inverse of both sides. So you get theta equal to, on the calculator, you should get 30 degrees, which is the same as pi over 6. Okay? So the first theta is going to be 30. The way you get the second one is to take 180 degrees and subtract the one you found with your calculator, giving you 150. So these two solutions are the only angles that give you 1/2 on the unit circle. So if you look at the circle, you'll see that it's these two locations that gives you this, right, for the y value. But let's pretend that it wasn't equal to an easy number. Let's assume that was like 0.27. Then you would get some weird angle, and you would have to do it this way. So use the calculator and then find the second set by subtracting from it. So once you have this, you can find all solutions. So if they just say solve without telling you one period, then assume all solutions. You guys cool on part A? Does that make sense?
Yeah,
Yeah.
we're just isolating like the equation on one side.
Mm-hmm.
Okay.
Yeah, that's a good thing to mention. When you're solving trig equations like this, you want to get the trig function by itself. And because you're trying to isolate the theta in here. Okay. So once you get there, get rid of the sine, and then you get your angle from the calculator. Use this angle to find the second one. Once you have these two, in order to find the end solution for all theta, all you got to do is take the one you found and add 360 degrees times n, and theta 2, which is 150 degrees plus 360 degrees n, where n is an integer. And if you're wondering why the heck am I putting that n there, it's because, let me see if I have the downloads here. Do not. Open up a unit circle. Okay. So 30 plus 360n. So 30 degrees, right? You see the solution right there. Without doing any work, you can see it. Y is 1/2. Sine is 1/2 at this angle. 180 minus 30 gives you the other one right there. 1/2 at 150. Now, if you add 360 degrees at the 30, you're going to get another solution because I'm back at the same spot. Add another 360, I have the same spot again. So that's another solution. Subtract 360 over and over again. If you'll keep landing here, which is your solutions. So basically any multiple of 360 where n is some multiple, right? If you keep adding any for any n, negative or positive, you will get infinite solutions. So each one creates an infinite set of solutions. So all you got to do is to cover your bases is take the original two answers and tack on the 360n. Because n is just an integer. Does that make sense?
Yes.
Okay. So let's do another one.
Is there a limit, like in the homework, would there when you're doing it, would it just take like a certain amount of answers, or is like 2 or 3 of each?
And the homework, you're going to solve these guys and you're just going to tack on. So
Oh,
they
I
use 2 pi n. So just instead of 360n, you use 2 pi n.
okay.
So yeah, just write it like this. You have one solution set and then another one. But I wanted to start out with some easy numbers first. Okay, let's go ahead and do example 2. And problem 6 will be example 2. So you guys cool on example 1?
Yeah.
Okay. So they give you 3 cosine theta plus 2 equal to negative cosine theta. So solve for cosine. So if I add this over, right, I'm going to get 4 cosine plus 2 equal to 0. So 4 cosine, subtract the 2 gives me this. Divide by 4 gives me a negative half. So very similar to the last question, except we had to do some work to get here, right? Now introduce your inverse. You get theta equal to, calculator will say 120 degrees, or in radians, 2 pi thirds. So your first solution, so what you want to do is find the first one, right, for one period. Let's subtract, for cosine, you want to subtract from 360. So that'll be 240 degrees. 120 is the same as 2 pi thirds. We said that already. This one will be 4 pi thirds. Okay. All right. So we got our two answers, but they didn't mention one period on the question. Check out the question. It says solve the equation. Use n as an integer constant. So we need to use that n thing to get the answer. Here they're asking for radians. So I'm gonna go ahead and use this one. So the first solution set is 2 pi thirds plus 2 pi n. The second set will be 4 pi thirds plus 2 pi n. So instead of adding 360, I'm adding 2 pi, which is the same thing. Is there any questions on problem 6? Does that make sense? Is that weird?
No, it makes sense.
Yes, it's not too weird, right? So the only thing, just make sure you use your calculator to get this. And just change it to radians if the homework wants radians. Okay. Because if you leave it in radians and use your calculator, you're going to get some ugly decimals, so it won't be pretty like this. So if you do this first, you can just change it with the unit circle. That'd be easier. Okay, let's do problem 8, because this is the same type of deal. This is more of a quadratic type, so it looks more interesting. Problem 8, okay. So for cosine squared x minus 1 is equal to 0. Okay. It just says solve, but use radians. So add the 1 over, divide by 4, square root both sides. When you square root both sides, you got to tack on that plus or minus. So you get cosine x equal to plus or minus 1/2. Again, we have 1/2. I guess it's not interesting, but this plus or minus part makes it more interesting. So now we have cosine x equal to 1/2 and cosine x equal to -1/2. So use your inverse function on both of them, right? So cosine inverse of both sides to solve for your angle. Cosine inverse of both sides, solve for your angle. So we get x equal to cosine -1/2. Okay. We got what? Last time we got 60 degrees, right? Or pi over 3. -1/2 though. That'll give us, we'll call this x1, I guess. x2 would be, we said we subtract from what for cosine to get the second set?
360.
Yeah. So minus, gives us 300, which is 5 pi over 3. Do this guy, get another 2 sets. So we'll call it x3. These cosines will cancel. Cosine inverse of -1/2. That is 120 degrees or 2 pi thirds. Find the other set of this guy. 360 minus 120, 240. which is 4 pi thirds. All right, I know I went a little fast there. So from the top, right? Isolate cosine. Square root if you have to. This creates two equations. Cosine equal to half or negative half. Introduce inverses on both sides to find your first set of angles. Once you find those, subtract from 360 to get the second set. I'm changing them to radians because they said radians. But calculator is easier to deal with on the degrees. Okay, you guys still with me up to this point?
Yes.
Okay, so just tack on the 360 or 2 pi n and we're good. So we got pi over 3 plus 2 pi n. We got 2 pi thirds plus 2 pi n. We got 5 pi thirds plus 2 pi n. We have 4 pi thirds. So this is my solution set. Are there any questions on how we got that? That's interesting. Check it out. We said pi thirds, 2 pi thirds, 5 pi thirds over here, and 4 pi thirds there. They condensed it a bit and said, you know what, we can just add pi and condense it into 2 sets instead of 4. Because from here to here, double check here. If I add pi, I get to 4 pi thirds. If I add pi again, I get back to pi thirds. So you can just use this one to get 2 at once. You see what I mean? Instead of having pi thirds plus 360 over and over again, and then 4 pi thirds plus 360, you can kind of merge it into one and just say, well, it's just from here to here to here over and over again forever. Does that make sense? So basically, I'm going to underline them. This one and this one can be represented with pi third plus pi n. And these two can be represented by 2 pi thirds plus pi n. These are both technically the same solutions. It's kind of like when you're doing coding and you find a smoother way to do things. This would be like the compact version, which is better, but this technically works. Does that make sense?
That makes sense.
All right, cool. And on an exam, I would accept either one. It's the same thing. I don't know what your homework will take, but it should take both. And if not, you will have to condense it. All right, I'm gonna move on a different one. To number 9. Here we gotta do some factoring. Check it out. You guys cool on the last example?
Yes. Yes.
All right. Same deal here. Isolate in factor if you can, and then use your inverse stuff. So here you see cosine is a common factor, right? GCF. So once you factor and equal to 0, you can set each one equal to 0. So this becomes true, right? Well, let's skip that step yet. This technically square root both sides and you get plus or minus 1. I skipped a minor step here. This time, instead of using the inverse, well, now let's keep practicing. Take the inverse of both sides. You will get that x is equal to 90 degrees. So its pair will be 360 minus 90, which is 270. 270 is 3 pi over 2, right? So now, again, cosine inverse of cosine of plus or minus 1. Here, I think we should use the circle a little bit because this becomes x equal to 0. And this one becomes x equal to pi or 180, right? Okay. You guys cool up to this point. We did the factoring, we isolated the cosines, we got multiple pieces that you had to find the angles for. What angle gives you 0? What angle gives you plus or minus 1? Okay. Any questions on this part so far? Okay, so it'll be 0 plus 2 pi n. Um, 90 plus 2 pi n. 180. I'm sorry, pi. And 270. Dang it. 3 pi over 2. So you can condense this if you want into just simply, these all just differ by 90 degrees. So you could just say 0 plus pi n, right? When n is 0, you get 0. When n is 1, you get 90 or pi over 2. When n is 2, you get pi. When n is 3, you get this, and so forth. Any questions on example 4? That's what they got. Pi over 2. Oh, actually, what I miss? Oh, yeah, you're right. Shit. Okay. Dang it. Yeah, it would just simply be multiples of pi over 2. My bad. But I guess you could have said 0 plus pi over 2n, but the 0 doesn't do anything, right? It's the same thing. All right, guys. So far, is this idea making sense to you?
Yes, makes sense. So if it's just single equation with like no quadratic, you're just isolating and then finding the equation based on the period, like 2 pi.
Yeah.
So we get the periods from like cosine, or if it's a cosine, it's gonna be pi or 2 pi. Sorry, that makes
Yeah.
sense.
Just think of the well, just visualize it and like look at the circle. So like if you know one of the solutions is, I don't know, 60 degrees, then if I keep adding 2 pi, I'll keep hitting that number, right? But to find the pair, you got to subtract from 360 if you're doing cosine, and subtract from 180 if you're doing sine. All right, guys, let me take roll. I guess we'll stop here. Give me a sec. Is Aaliyah Carmichael here?
Yes.
Jamila?
I'm here.
Gabriel Eastridge?
Here.
Victoria Espinosa? Okay, Haley Gibson?
Here.
Brianna Johnson?
Here.
Blanca Mendiola? Now here, Gavin Montemayor?
Here,
Priscilla Ott?
Here.
Matthew Packard?
Here.
Serena Rayburn?
Here.
Jose Reyes?
Here.
Natasha Rosca? Monica Vasquez? Vanessa Ventura?
Here.
Zachary Villarreal?
Here.
Jeremiah Williams?
Here.
All right. Okay. Yeah.